the problem on the right here, we're going to try and solve for 5 sine squared theta plus 4 sine of theta equals 0. So, just like before, think of it like this. If I have 5x squared plus 4x equals 0, what can I do to solve this? Now, the easiest thing to look for is, oh, there's an x in both. I'm going to factor an x out. Okay? Then I have 5x plus 4, and that equals 0. We do the same thing over here. We're going to see that we just have a sine we can factor out. So if we take a sine of theta out, I get 5 sine of theta plus 4. Remember, if you distribute it back, it should give us back what we originally had. So the next thing is we're going to set both of them equal to 0. Just like we did over here, we have x equals 0 and 5x plus 4 equals 0. Over here we'll have sine of x equals 0. I'm sorry, sine of theta equals 0, and 5 sine theta plus 4 equals 0. Right? So this one's already solved, sine theta equals 0, but we also have to deal with this one over here. Subtract 4 and divide by 5, so we get sine of theta equals negative 4 fifths. By the way, if we solve over here, we get minus 4. And you can see we still get 5x equals minus 4 divided by 5. Same thing. Okay. However, when it's trigonometric, we still have to determine what our final answers are. All right. So the next question is when is sine 0? Well, sine is 0 at 0, actually. Okay. It's also at 180, and it's also at 360. Think of it as the y-coordinate on the unit circle. So back to our unit circle. There it's 0, and there it's 0. And then when it comes back around, it's 360, because that's coterminal to 0. The one thing we have to realize is we have to look at the interval of our problem. It says between 0 and 360, but it also includes the endpoint. So our final answer for this, at least this piece, is going to be 0, 180, and 360. We have to watch out, though, because sometimes we might ignore the fact that it's equal to. Or they might actually write it as 0 is less than theta, is less than 360, and include one or the other. So they might include that one includes 360, but not 0, or I could include 0, but not 360. So that one's given there. We have 3 solutions for that one. All right. The other one we have to look at is when sine of theta equals negative 4 fifths. All right. Now that one we're not going to know, so we're going to have to use our calculator here. So bring up my calculator, and I say to myself, all right, well, I need the arc sine of negative 4 fifths. And that is negative 53.130100235. Okay, it's a nasty number. It's never going to come out nice anymore when we don't have ones we know. So then I'm going to have to take a look and say, all right, well, that's our reference angle if we ignore the negative sign, 53.13. So if I just do multiply it by negative 1, I get our reference angle. All right, so I'm going to use that right there as our reference angle. Angle, and that's going to be 53 degrees, 3.13. All right, we're going to do this to the nearest tenth as well. So we'll call it 53.1. All right, we need to know when sine is negative. Sine is negative in quadrants what? Well, all students take calculus. All in the first and sine in the second is positive, so Q3 and Q4. In Q3 it's 180 plus our reference angle, so 53.1, and in Q4 it's 360 minus 53.1. So our final answer, 1 and 3, 3 point. Okay, 5 and 8 give me 3. And 2. So 233.1 degrees is one of them. And over here we have to do a little bit of subtraction, which is going to be 306.9 degrees. Okay, so our final solution of all this is going to be theta has to equal 0, 180, 233.1, 306.9, and 360. A lot of solutions just in that one little interval. So make sure you keep track of them all. And we have our final solution.